So last time we solved systems by what method? Do you guys remember? Which method do we use to solve systems? Like when you have two linear equations together, we graph, and what was the solution? Yeah. No, the line wasn't the solution. When you have systems of linear equations, remember we did graphing method last time. What was the solution, Kevin? Yeah, what is that point? Verge? Oh, no, okay, we did the inequalities the day after that, but the day before, when we just had two lines, where the two lines intersect, that was your solution, you guys remember? And of course, when we did the inequalities the day after, right, it's the same thing, you just have to shade it below or above, and wherever two of them, where the two shading regions overlap, that was your solution, you guys remember? Now, today we're going to learn another method of solving now equations, systems of linear equations. It's called substitution method. Okay, so it's not going to involve graphing. Even though graphing was kind of nice, there were some limitations. Did anybody realize when you were doing the homework on 9.1, you know, when you have two lines, what was your, did you guys, was there some sort of limitation in terms of finding the solution? Raise your hand. Pecco. Yeah, if the intersection happened to be some fraction, right? In other words, when you're graphing them, you would not know exactly where those intersections might be. Yeah, on your homework last time was nice, right? It was right on the grid, right? So you could tell, like maybe it was 2, 4 or something. But what if it's some fraction? You don't know exactly what those intersections represent. Also, there's another limitation of graphing when you graph. Get it? Well, if they're parallel, you just write what? No solution. There's another limitation though. Anybody realize? Does anybody know what other limitation we have in terms of graphing? Was. Okay, do the intersection have to be, what if the intersection is like way off of your graph? Like for example, if the two lines intersect at, I don't know, 2 million, 5 trillion or something. It won't be that big, you know what I mean? But the intersection does not have to be within your, if it goes off of your graphing paper, right? It will be very hard to find your intersection. You understand what I'm talking about? So today we're going to learn substitution method, which is a method where it does not involve any graphing. Okay? Does that make sense? Now, graphing was kind of nice though. How was graphing method nice? Yeah, you were able to graphically what? See where the intersection was. You see what I mean? But in these algebraic method, which is one of them is called substitution method, where it does not involve graphing, you don't really get to see the intersection. But you know that's what's happening, okay? So write this down. In the substitution method, so how do we then use the substitution method? In the substitution method, we use either equation, write this down. We use either equation to solve for one variable in terms of the other. Okay, that's the first step. Then, okay, go ahead and write this down. Wait. Then, after that, you obtain a third equation involving one variable by substituting. Okay, so write that down. Let's see what that means. Okay. So it seems kind of long, but it's actually in real practice. As we do this, you will see that it's not that. Yeah, it's not that hard. So go ahead and write it down. Very good. So some of you remember, you might have done this in intro. Very good. So for example,
I don't remember any of it. But
oh, okay, so that's okay, because then it will really help you. So look at example 1. It's going to ask you to solve by substitution method. And here's my first example. Okay. So as you can see, look at the one. So it says, look at what it says. In the substitution method, we use either equation. So which one should I use? The first one or the second one to solve for one variable? The first one is the, okay, we could use the first one. We could use the second one, doesn't matter. So let's use the first one. How do I solve for one variable? Which one would you like to solve for? X or Y? Y. Why? How come you don't want to solve for X? You could, but why is solving for Y better? Yeah. Yeah, and not, which means that you won't get any fraction. You see what I mean? If I solve for x, you'd have to divide both sides by 2, so you're going to get some fractions. You don't want to deal with fractions, right? And so much as, if you could avoid it, why not avoid it? By solving for y. So how do I solve for y on the first equation right here? What do you do? Yeah. You subtract 2x from both sides, is correct. So when you do, you get y equals to negative 2x plus 9. Is that okay?
It's alright.
Very good. So then, once you get that, what you do is you plug in that y into the other equation. That's why it's called the substitution method. You substitute it in. You plug it in. So because what it's saying right here is y is equal to negative 2x plus 9. So when you substitute y in here, you get. Can somebody tell me what I get if I were to put it in?
Ooh.
That's my third equation. You see what? You see where it says the third equation?
You combine the
Then,
two equations to make a
then
superior
exactly.
equation.
Then obtain a third equation involving only one variable. Notice what happens as you plug it in. Somebody tell me what to write. Yeah, Jennifer. That's exactly right. And like Caleb says, this is how we get the third equation. Notice something that's nice about this third equation. How many variables do I have in this third equation? Only one. Whereas the original equations had how many variables? 2. So we didn't know how to solve those by itself, right? Now, after you substitute it in, look at all the variables are x, only one variable. We know how to solve this equation, don't we? So we distribute. Everybody go ahead and try. I'll try. Finish it up. Let's see what you get, okay? What's my next step? Courtney, tell me what to write.
After you distribute, it
Yeah.
becomes x minus 8x plus 36 equals 1.
Good.
And then it becomes negative 7x plus 36 equals 1.
Good. And do we know how to solve these type of equation? Yeah? These are easy, aren't they? So then when you solve, did you all get x equals to 5?
Yes.
Very good. And I'm done, right?
No.
No, you're right. How come I'm not done?
You gotta plug it in, plug it in.
That's okay. Very good. What? How come this is not my solution? Yeah. Okay. Very good. Remember when the two lines intersect, what does the solution look like? Is it an order pair? What do I just have now? This is just the x coordinate of the order pair. So, see, isn't this the only x coordinate? And just like Caleb said, we have to plug it in to figure out y. Now, where do we plug this into then, Caleb? You said to plug in. What do you mean by which equation?
The second one. First one. One of them. It's one of them.
Okay, there is not. Okay, yes, Theater.
The third one.
Hold on, Theater. Yeah, so you could plug into where you solve for y, or I normally we just plug into the original equation. Now, which one should we plug it into? Remember we had two equations, the original one. Should we plug into the first one or the second one?
What did Caleb say?
The first one. How many people say first one? Raise your hand. How many people say second one?
I said it's.
Oh, you always okay. So it turns out it does not really matter. You could choose any one you want.
See, I said it's any one. I said it's
So
any one of them.
So the answer. Then this is the question. How do I find the y coordinate? Right? We know the x coordinate. Well, the answer is you plug in x coordinate into any of the original equation. Remember we had two. So I happen to choose the first one. But how come it doesn't really matter which equation you choose? First one or the second one? Can somebody answer that? Very good. Okay, hold on. How about Sasha? Why does it not matter?
Both of them have y in it, so we can solve for y.
Okay. Now, that's not really the really. Yeah, Tina.
They're in the same system, so you can use both. So, because no matter which one you use, you're still gonna get the same thing.
Okay, you're saying it. Okay, who can summarize what you just said? Why does it not matter to find y? Right? You could use the first equation or the second equation. Stephanie. Oh, okay. Kate. Because they give you the same answer. Yeah, kind of. Somebody, Kevin. They both intersect at the same point. So the order pair that we get is what? Solution for both of these equations. It doesn't matter which one you plug it into. Does that make sense? Yeah. You just basically choose the easier one because it was better to give you the same y coordinate. Does that make sense? Because that's where they intersect, right? And that's the solution of both of those lines. You know what I'm talking about?